Hello, and welcome to our channel. Let us start with the permutations and combinations. Permutations and combinations are a crucial aspect of probability and require clear understanding to solve the related problems. Let's take a common examples in permutations and combination. Imagine you have three colored balls, red, blue, and green. In how many different orders can you arrange them? That's permutation. Whereas, combinations are about picking a certain number of things from a group, but the order doesn't matter. If you want to pick two balls at a time, how many different pairs can you make? That's combination. So, permutations deal with the order of things, while combinations are more about selecting without caring about the order. So, technically, permutations involve the arrangement of elements in a specific order, and the keywords here are arrangement and specific order. That means the order matters in case of permutations. For combinations, it is about selecting the elements without considering the order. So, the order doesn't matter in combinations. If you understood this difference between these two, you can very easily conceptualize and solve problems related to permutations and combinations. Consider a set of three flowers, rose, daisy, and lotus. Now, imagine taking two flowers from this set as subsets, rose daisy and daisy rose. Now in permutations, rose daisy and daisy rose are two different permutations. Since the order is being considered, in the first subset, rose is in first place, whereas daisy is in second place, and in the second subset, daisy is in the first place and rose is in the second place, while in case of combinations, both these subsets, rose daisy and daisy rose, are considered the same because the order doesn't matter here. Now let us first explore permutations. Consider n to be the total number of different objects, and r be the number of objects considered at a time, where r will be between 0 and n. Now, imagine we have a digit locker with us, where there are 3 slots available, and we wish to set a lock with 3 possible digits, 0, 1, and 2. For example, 0, 1, 1, or 1, 0, and 2. Here, we are seeing that even for the same digits, if their positions vary, that will lead to different lock patterns. That means the order matters here. Let's talk about repetitions of these digits now. Are repetitions allowed or not? Consider that we can use one digit more than once for creating our lock pattern. Therefore, the repetitions are possible if desired. In that case, the permutations possible or the number of ways in which we can set the lock will be written as NPR, which denotes the arrangement of R out of n objects, which is equal to n to the power R. For the example which we have considered, we have 3 places where we can adjust 3 digits with repetitions. So, total number of ways possible here will be 3 to power 3, which will be 27. Now suppose a case where we wish to keep all the digits unique. So, it will be case where repetitions are not allowed. Then, the number of permutations possible will be written as NPR, which equals n factorial upon n minus r factorial. So, for our example, we will have 3 factorial upon 3 minus 3 factorial, which will be 3 multiplied 2, that is 6 ways. Now let's talk about combinations, which is basically the selections where the order doesn't matter, along with the possibility of repetitions. Consider another example. Say a drawer contains a wallet, a watch, and a cell phone, and 2 of the items are to be withdrawn. First withdrawal was made randomly and the wallet came up. Now again, another item was withdrawn and this time it's the cell phone. Even if these items were withdrawn in other order, that is, the cell phone first and later the wallet, yet the combination of these two would have been same. So, this becomes the case of selection where the order doesn't matter. Also, when we have made the first withdrawal, we did not put it back before making the second withdrawal. So, here there are no repetitions or replacements happening. In that case, we can calculate the number of possible combinations as NCR, which will be n factorial upon r factorial multiplied by n minus r factorial. So, in our example, we have n as 3, and which we are looking at the combination of two items. So, we can solve it as 3 factorial upon 2 factorial multiplied by 3 minus 2 factorial, which upon solving will be 3. So we can make the selection without repetition in 3 ways. Now let's say we put back the first withdrawn item back in the drawer and then we make the second withdrawal. So now this is the scenario where you are replacing the item, or we can say that the repetitions are possible. In that case, the number of ways in which we can withdraw items with repetition will be n plus r minus 1 cr, or we can write this as n plus r minus 1 factorial upon r factorial n minus 1 factorial. That's it. So now when you solve this for our example, and it will be 3 plus 2 minus 1 factorial upon 2 factorial multiplied by 3 minus 1 factorial, which upon solving will be equal to 6 ways. Let's summarize our discussion now. What we discussed so far is that in permutations the order matters, and when the repetitions are allowed, the number of permutations will be n to the power r, and when the repetitions are not allowed, the number of permutations will be n factorial upon n minus r factorial. In case of combinations, where the order doesn't matter, when repetition is allowed, then number of combinations will be n plus r minus 1 factorial upon r factorial multiplied by n minus 1 factorial, and when the repetitions are not allowed, the number of combinations will be n factorial upon r factorial multiplied by n minus r factorial. Now let's take some examples. The first example problem says, in how many ways can we arrange the letters of the word Python? The word Python has 6 letters. You can pause the video here and try to solve it. Alright, the question asks us to arrange the letters. So, every arrangement will be different from one another. That means the order matters here. Another point to think here is whether there is a repetition or not. So, once we take any one of the letters and place it in our arrangement, we are not considering it back. Therefore, there is no repetition happening. In that case, we can find the number of ways of arrangement as NPR equal to n factorial upon n minus r factorial. Now, since we are taking all the 6 letters and finding the possible arrangements, so r is equal to n. Then it becomes 6 factorial upon 6 minus 6 factorial, which will be equal to 720 ways. Therefore, this is our solution. Now let's look at another problem. It says, in how many ways can we arrange the letters of the word Python code? So, the word given here has 10 letters. If we observe carefully, we will see that this is again a problem of permutations, where we need to make the arrangement of 10 letters, and we need to find the possible number of arrangements of 10 letters. Here we have r equal to n, and we can calculate NPR, which is equal to n factorial upon n minus r factorial. Additionally, when we look at this word carefully, we observe that O is being repeated twice here. In such cases, we have to divide n factorial by the number of times any letter is being repeated, so we divide it by 2 factorial. Then we get 10 factorial upon 2 factorial, and this is the number of ways in which we can arrange the letters of this word. Let's look at our third problem now. It says, in how many ways can we select any 3 consonants from word Python? So, in this word, Python, we have total 5 consonants, from which we are asked to select any 3. So, we can apply combinations without repetitions here to select 3 consonants out of 5, which will be 5 factorial upon 3 factorial multiplied by 5 minus 3 factorial, which is equal to 10. So, we have 10 ways in which we can select any 3 consonants out of 5 consonants in this 6-letter word. This was all about permutations and combinations that we need to know. With this approach, we can solve any related problem. I hope you enjoyed watching this video, and it was a good learning experience for you. If so, do like this video, and please subscribe to our channel, in case you have not done that yet. I'll see you in the next video.